The members of a men's club have a choice of wearing black or red vests to their club meetings. A study done over a period of many years determined that the percentage of black vests worn is 60%. If there are 10 men at a club meeting on a given night, what is the probability to the nearest thousandth that at least 8 of the vests worn will be black? Okay, so this is a probability problem, and they want to know the probability that at least 8 of the vests worn will be black, right? And before we start to get into the formulation of this, you should already be starting to make a prediction as to whether this is a likely event or not. Even if you have no idea what the exact percentage would be, have a position about whether this is likely, relatively likely, unlikely, highly unlikely. What do you think the chances are? So it says that the percentage of black vests worn is 60%. So that means that if a member is getting ready and he's putting on his vest, there's a 60% chance that he's going to wear a black vest. So every single member selecting the color of their vest can be considered to be an independent event. Nobody's conferring and saying, what color vest are you wearing? They're completely independent events. So there's a 6 in 10 chance that a given person chooses to wear a black vest on a given occasion. So that's going to be the premise for our problem. And they also tell us that there are 10 men at each meeting. So that's something we're going to need as well. So we've kind of extracted the given information here. How do we actually go about calculating the exact probability that there'll be a particular number of members wearing a black vest on a given night? Well, for this problem we're going to use the binomial equation. So the binomial equation allows us to calculate the probability of exactly x successes. So x is going to be the number of successes, and we'll define that in a minute. And this formula tells us what that is. So n is the number of trials, and it's the combination of n trials with x successes times the probability of success raised to the number of successes times 1 minus the probability of success, which is the probability of failure, raised to the n minus x. So that's the trials that did not succeed. Alright, let's be a little more specific and define this in terms of this particular problem. So how many successes do we want? Well, what is success? In our case, we want to know the probability that at least 8 of the vests worn will be black. So we're going to consider wearing black, for a member to have worn a black vest, that's considered a success. And each member at the meeting, of which there are 10 members, represent an individual trial. So every meeting has 10 trials, 10 men, and a success is if that man wore a black vest. Okay? So in this case, x being the number of successes, how many successes do we want to have? Well, we want to have at least 8. So we want to have either 8 or 9 or 10. So x is going to equal 8 or 9 or 10. And I'll get a little bit ahead right here. I just want to mention this formula can't calculate the probability of at least 8 of the vests worn, because there's 3 possibilities. It could be 8 or 9 or 10. The formula can only calculate the probability of it being exactly 8 black vests, or exactly 9, or exactly 10, depending on what we choose as our value for x. So we actually have to use this formula 3 times and then add up the probabilities of these separately. We'll get to that. So x is the number of successes. There's 3 choices. N is the number of trials. So since there's 10 men and the selection of the color of the vest for each man is an independent event, there's going to be 10 trials. So n equals 10. This is a combination, so we're going to do ncx or 10c and whichever value of x we're using. I'm not going to go into detail about how combinations work in this video, but if you want to go back and brush up about it, there may be some other problems you can look at. And then the probability of success, we're defining success as wearing a black vest. And the probability for any one independent trial of wearing a black vest is 60%, so that's our probability of success. P equals 0.6. That's the same way of saying there's a 60% chance that an individual wears a black vest. 1 minus P is the probability of failure. We don't actually have to write out what that is, but we can. It's the probability of wearing a red vest, which is the probability that he didn't wear black. So 1 minus P, I don't like the way that's written, 1 minus P is naturally going to be 0.4 or 40%. If the chances of it raining outside are 60%, the chances of it not raining are 40%. Same with this. They only have two color choices for what kind of vest they're going to wear. And then that's raised to the number of trials that were not successes. So n minus x, where there's 10 trials and x successes. So we've already defined n and x. We don't actually have to go back and do what that is. Okay, so hopefully that's fairly intuitive for you. There are simpler problems that you can do that use the binomial equation. In this case, we're going to be using it 3 times and then adding those probabilities together. So let's write these out. So let's calculate the probability that exactly 8 of the men wear a black vest. First of all, if you had to guess how many of the men were going to wear a black vest without doing any math at all, and you know there's a 60% chance, what would you guess? You would probably guess 6, right? 6 out of 10. That's the most likely scenario. So what's the chances that 8 out of 10 are going to do it? It's probably a lot less. It's probably unlikely, right? So we should expect this to be a low probability. And then what about the probability of 9? That's even less likely. And 10, even less likely still. So we should see that P8 is the biggest of the 3. P9 will be smaller and P10 will be the smallest. Okay, so P8 is NCX, so there's 10 trials, and we want 10 in combination with 8 successes, and the probability of success is 0.6, and that's raised to the 8 because there's going to be 8 successes, and then that's multiplied times the probability of failure, or the probability of a red vest in this case, 0.4, and that's raised to the n minus x, which is 10 minus 8, which is 2. Alright, so when you put that into your calculator, 10C8 is, I believe, 45, and then, I don't know these in my head, so I put them into my calculator. I got 0.12093. And our final answer is going to be to the nearest thousandth, which is the third place after the 0, so I'm carrying 5 just to be safe, because we're going to do some calculations with these numbers after we get them. What does this mean? There's a 12% chance that exactly 8 members wear a black vest. I'm going to do the same for P9 and P10. P9, we have 10C9 now, because we want 9 successes. 0.6 to the 9. And again, probability of failure is still 0.4, but now it's 10 minus 1. I'm sorry, 10 minus 9, which is 1. Notice that this and this will always add up to 10, to the number of trials. So in this case it's 8 and 2, in this case it's 9 and 1. It always has to add up to the total number of trials. Put this one in the calculator as well, and just as predicted, it's smaller, because the chances of this are less. And finally, P10 is the least likely of all. 10C10, which by the way is 1. How many ways can you take 10 things from a group of 10 things? There's only one way. 0.6 to the 10th, because they're all going to be successes. This means all 10 members wore a black vest. Times the probability of failure, which is 0.4, but now it's raised to the 0, because there's no failures. Nobody's wearing a red vest. And that came out to be 0.00605. So it's just as predicted. They go in order. They're decreasingly probable as we ask more and more people to be wearing a black vest. So now what do we do with these numbers once we get them? Well, we're asking for the probability of at least 8. So if these are the probabilities of 8, 9, and 10 respectively, we want to know the total probability of any of these things happening. So really it's like 8 or 9 or 10. And what do you do with or? You add them. That should be intuitive for you. It's this or that or that. The total probability is any of them could happen, so it should increase. If you multiply these numbers that are less than 1, it's going to get smaller. So when you have the word and, that's your clue that you need to multiply. When you have the word or, that's your clue that you should add. And when you go ahead and add these all up, you get 0.1672. 9, and then we need to round that to the nearest thousandth, so we're going to just keep 3 decimals and round off. We'll get 0.167. So there's a 16, or you could think of this as a percentage too. You could think of this as there's a 16.7% chance that at least 8 of the vests worn will be black.